Hi, I'm Professor Kelly, and this is a lecture on the terminology of the procedural paradigm for CS/CI 308 Programming Language Design. The learning goals for this lecture are to be able to define procedural paradigm terminology, recognize occurrences of each term in code, and give an example of each term in code. The procedural paradigm is any imperative language that has functions and procedures. It first appeared in the late 1950s with the languages Fortran, Algol, COBOL, PL1, BASIC, Pascal, and C. Object-oriented languages are technically procedural paradigm languages. They kept the functions and procedures, but added objects. You may remember side effects from the memory hazards video. A side effect is when a change escapes the current code running. All imperative languages have side effects. Side effects include a change to memory, such as when a value is assigned to a variable, regardless of whether it's on the stack or the heap. Input from a file or from a user, or output to a file or screen. An expression is something that has a return value but no side effects. For example, 3 plus 4 is an expression that returns 7. A statement has side effects but no return value. For example, assigning 7 to the variable x. Declarative languages only have expressions. Declarative languages include Haskell, Prolog, and Lisp. They may steal a few statements, but more or less, when you write code in Haskell, Prolog, or Lisp, you are only writing expressions. Imperative languages embed expressions inside statements. For example, in this if statement, we have the test, which is an expression, x is less than 3. However, the code executed by the if statement is a statement. Some operators create code that is both an expression and a statement. For example, the plus plus operator in C++ or Java. For example, I++ will return a value and increment the value by 1. Functions have return values, but no side effects. Here's an example of a function in Fortran. It's not the full function, just the declaration. This function takes a set of data and finds the median value, then returns it. Procedures have side effects, but no return value. Here's an example of a procedure in Fortran. In Fortran, they're called subroutines. This subroutine reads from a file. The whole point of this subroutine is a side effect, reading from a file, and as such, it is best implemented as a subroutine. Functional languages only have functions. Procedural languages have both. C++ and Java, functions in those languages with void return values are actually procedures. Referential transparency is when a function or expression can be replaced with its return value without changing the program's behavior. For example, in Haskell, all functions are 100% referentially transparent. We can substitute all instances of this function foo with an anonymous function, and then we can substitute all instances of foo7 with its final value, 10. Anytime we see a foo7, we know the result is going to be 10, so we can copy and paste, replacing all the foo7s with 10. Referential transparency is useful for proving code correctness. It's also useful for code optimization. Something is referentially transparent only if the function has no side effects. This is true of all functions in mathematics, as well as functions in all functional languages such as Haskell. The opposite of referential transparency is referential opacity. This is when the code has side effects. That is to say, it's actually a statement or a procedure. For example, here in Python, we have a function foo that is 100% referentially transparent. It returns x plus 3. There are no side effects in this function. We could easily copy and paste and replace all foo7s with 10. Foo2 here sort of has a side effect. It's writing to the stack. However, the value written to the stack gets deleted when the stack frame is popped, and so the side effect ends up being deleted and not mattering. So foo2 is also referentially transparent. Here's another example. Here we have a global variable z. We modify the z when the function is called. So let's see what happens. When we call foo on 7, we get 10. If we call it again, we'll still get 10. Same with foo2. 10, always 10. Conversely, the first time we call foo3, we get 10, but the second time we call foo3, we get 11 because of the change in the state of the global variable z. As a result, foo3 cannot be substituted for its return value because the return value changes due to side effects. An argument is the input to a function when the function is called. Parameters, on the other hand, are the inputs to a function in the function definition. An operator is a symbol performing an action. In 3 plus 4 times 5 here, the plus and multiply symbols are operators. The operands are the variables being acted on. 3, 4, and 5 are operands. A sub-expression is an expression used as an operand, such as 4 times 5. Unary describes an operator that takes one operand, such as I++ or -i. Plus takes one operand. Minus also takes one operand, making the variable negative. A binary operator takes two operands. Plus is an example of a binary operator, and so is modulo. Different languages put operators in different places. Infix notation is when the operator appears between the operands. Infix notation is used in C++, Python, Java, Prolog, and Haskell. Prefix notation is when the operator appears before the operands. This is used in Ada and Lisp. Postfix notation is when the operator appears after the operands. Postfix notation is rarely used. It's used in the PostScript language, however, which is the basis for the PDF file type. Mixfix is when an operator appears in multiple places at once. An example of mixfix notation is the if-then-else operator. If-then-else is all one operator that determines, given the value of A, whether B or C is returned. If-then-else in Haskell is not actually equivalent to if-then-else in an imperative language, but it is equivalent to the ::colon operator in C or C++, depending on the value of A, B, or C is returned. Here is a glossary for all the terms defined in this video.